Hey there, physical science students. This is Miss Ruark. I told you we would do this nice little vodcast for you so that you would know, um, well, how to answer all those questions that you had to work on in class, and you would know how to study for your test. So here's your review. All right, the formula challenge, just in case you missed it when we worked on it in class, here are all of your answers. If you need to, make sure that you pause this so that you can check it because I'm going to move on. Okay, question number 13. So we've got to analyze this question first. It says Goldie Goldfish, a speed swimmer, loves to race around the park's pond, which is 0.5 miles around. So that's going to be a distance. If she can swim a total of 20 laps around the track in 2 hours, which would be our time, what is her average speed? So we're looking for speed or velocity. Okay. So we know that we're going to have V is equal to D over T because we have a V, we have a D, and we have a T. However, here it says that she goes 0.5 miles around 20 times. Okay, so that's going to be 20 times a total distance of 0.5 for each time that she goes around, and we divide that by the time, which would be 2 hours. All right, so to solve this, 20 times 0.5 should be 10 miles. And we divide by our time, which would be 2 hours. And 10 divided by 2 is 5, so it would be 5 miles per hour. And that would be how you solve the first one. Okay, now remember, I'm going to go through these kind of quick. If you need to pause, rewind, feel free. Watch again, feel free. All right, it takes Stu, a slimy slug, 20 minutes to travel from his favorite bush to the local trash can, which is a trip of 20 or 30 meters. Okay, so in 20 minutes time, he can go a total of 30 meters, which is distance. So how far can he travel in 1 hour? So in 60 minutes, they want to know how far can he travel. Look, we've got another time. All right, so here we've got an initial time and an initial distance, and here we have a second time, and they want to know how far, so we're looking for a second distance. So on this one, you're doing a comparison, and when you're doing a comparison, set it up as a proportion. We know velocity is equal to d over t, so we can take d over t and set it equal to d over t. So our first d, or d1 over t1, is equal to d2 over t2. So d would be 30 over 20, and we're saying if he can travel 30 minutes or 30 meters in 20 minutes, how far can he travel in 60 minutes? Here we go. All right, it's a proportion, so now we cross multiply. So 30 times 60 gives us 1800, and that's equal to 2x. Well, solve for x, divide both sides by 220, not 2. Sorry, and x would be equal to 90. So he can travel 90 meters in 60 minutes. Okay, and yes, there are other ways you could do this, but that one's the one that works for right now. Okay, number 15. At exactly 2 o'clock p.m., Speedy the snail crawls onto a meter stick at the 10 centimeter mark. So here's my meter stick. Okay, Speedy the snail climbs on at the 10 centimeter mark, and this is at 2 o'clock p.m. He reaches the 65 centimeter mark at 2:10 p.m. Now you want to know what is his speed, all right? So we've got a distance, we've got a time, we've got a time, we've got a distance, and they want to know speed. So what equation am I going to use? Well, I'm going to use V is equal to D over T. The problem is they give us 2 times and 2 distances. So this would be kind of like the change in time over the change in, or the change in distance over the change in time. So we would do our final for our distance, 65 minus 10 over 210 minus 200. This gives us 55 centimeters in 10 minutes. And now we just solve, and we say that it's 5.5 centimeters per minute. All right, number 16. If it takes Leaping Louie 15 minutes to jump 3 blocks, how long will it take for him to jump 15 blocks? All right, so he's going 5 minutes, and he's going to go 3 blocks. And it says, how long will it take him to jump? 15 blocks. So here's another distance. How long will it take means time again. So here's time 1 and distance 1. We're looking for time 2, and we have distance 2. So we set this up as another proportion. So 3 blocks over 5 minutes, and that's equal to 15 blocks over time. All right, we solved for this. We've got 3 blocks times t. Why are you keeping blocks, Ms. Rourke? Because that's your unit. All right, and then on the other one, we've got 5 times 15 is, brain can't function right now. I don't know. Let me grab my calculator. I thought I could do it on my own. I probably can, but no. Brain doesn't want to work. 75. There we go. All right, 75 blocks times minutes. All right, we need to get rid of 3 blocks because we want t to be by itself, so we're going to divide both sides by 3 blocks. Blocks cancel. 3 blocks cancels. We're left with t, and t is equal to 75 divided by 3 is 25 minutes. So it's going to take them 25 minutes in order to travel 15 blocks. All right, if Bert the bat travels eastward at 40 miles per hour, but he has a tailwind of 6 miles per hour, so his tailwind is actually dragging him back this way at 6 miles per hour. What's his actual speed? Well, his actual speed should be 34 miles per hour. He's not going to go faster. He's going to go slower because it's pulling him backwards. All right, number 18. Toon Train is traveling at the speed of 10 meters per second. So this is our speed or our velocity at the top of a hill. 5 seconds later, ooh, that sounds like a time, it reaches the bottom of the hill and is moving at 30 meters per second. What is the rate of acceleration? Oh, looky there. We're looking for acceleration. Here we have a speed, we have a time, and we have another speed. If he's traveling at this, that's what he starts at, and this is where he stops. That must be VI and VF. So now we're going to use A is equal to VF minus VI over T. We're solving for A, so VF is 30 meters per second. VI is 10 meters per second. And then T, or time, is 5 seconds. Okay, so now we just solve. 30 minus 10 is 20, so 20 meters per second divided by 5 seconds. So 20 divided by 5 would be 4. Do those units cancel? No. Why? Because we're looking for acceleration. And remember, acceleration has to have 2 things for time in the bottom. And since they're both on the denominator, they both combine. So it's going to be 4 meters per second squared. All right, almost there. Pete the Penguin loves to sled down his favorite hill. If he hits a speed of 50 meters per second after 5 seconds, so this is going to be our final speed, right? Because it's after 5 seconds, which is our time. What is his rate of acceleration? So we're looking for acceleration, but it doesn't tell us what his initial speed was. Okay, well, he's sledding down a hill. And I know you guys don't have a lot of snow here, and you don't really get to experience the thrill of sledding, which is that's a shame. But if you're sledding down a hill, you have to start somewhere. You usually start at the top of the hill. And if you start at the top of the hill, your velocity should be 0. Okay, so we're starting at 0. And we have VF and we have T, and we're looking for A. So now we plug in 50 meters per second, minus 0 meters per second over 5 seconds. And we just solve it. So 50 minus 0 is 50 meters per second divided by 5 seconds, and that's going to give us 10 meters per second squared. And that is his acceleration. All right, number 20, Monster Mike's truck. This decelerates from 72 meters per second to 0 meters per second in 6 seconds. Now, I told you guys that decelerating means what? Negative acceleration. So anytime you see decelerates, I want you to write negative acceleration. or negative acceleration. I don't care. Either one's the same thing. Okay, so they want to know what is the rate of deceleration. They want to know what is his rate of negative acceleration. We have this to this, which means this is our initial velocity, this is our final velocity, and 6 seconds is our time. So A, or negative A in this case, all right. So A is equal to VF minus VI, and that's over T. You should get a negative number here because he's slowing down. All right, so let's plug this in. Our VF is 0 meters per second. Our VI is 72 meters per second, and we divide that by our time, which is 6 seconds. Okay, so 0 minus 72 is a negative 72 meters per second. We divide that by 6 seconds. And 72 divided by 6 would be a negative 12 meters per second squared. So he's slowing down 12 meters per second squared. Okay, excuse me. A little bit more review. Distance versus time graph. We covered this in class, but let's do it again. All right, in a distance versus time graph, distance is here on your y-axis, time is on your x-axis. No, time is not on your side right now, but time is on the x-axis. Okay, if you have, excuse me, if you have a straight line, that means it is a constant speed. If it's a sharp straight line, it's a fast constant speed, which means the velocity is going pretty quick. Okay, straight line here, angled, that means it's a constant speed. Constant speed. All right, if it's a straight line going across, if it's horizontal, that means that it's stationary, means it's not moving. What kind of velocity does it have? No velocity. Okay, if it's a curved line, it's accelerating as time goes by, so it's speeding up as time goes by. And if it's a negative slope, it means it's going backwards or returning back to its original position. On velocity versus time, oh, let's go back. This one, remember, distance versus time, that's going to give us this as our slope, and that's giving us a velocity. On the other one, velocity versus time, velocity over time is the same thing as acceleration. So velocity versus time gives us acceleration. Make sure you pay attention to what it says is on your axes. Okay? If it's got a positive slope, it's a positive acceleration. It means it's speeding up. If it has a negative slope, that means it's slowing down. Negative acceleration. And if it has no slope, that means there is no acceleration. And if there's no acceleration, that means that velocity is constant. Make sure you know those. All right. One other thing. If you have from here to, okay, let's say that, I know, different path. Okay, let's say we're talking about displacement. One more thing. If we have displacement, okay, here's my course. Woo, we did all this running. Start line here. Finish line here. Okay, you ran 3.1 miles. That's the total, right? This whole long thing. But from here to here, this would be your displacement. And let's say the displacement's only, oh, I don't know, 10 meters. Or let's say, not even a mile, let's say it's like a quarter of a mile. Okay? Notice how the displacement is a straight line between 2 points. Your displacement's always going to have a vector too. So your start line and your finish line, if you wanted to say the finish line, the displacement for the finish line, it is 0.25 miles to the east. Okay, so make sure that you know those. All right, I think that's it. Good luck on the test tomorrow. Quiz. Sorry. Bye.